Afternoon. My name is Iain Hume. I'm with New South Wales Department of Primary Industries. This is a recording of a presentation given to the Australian Cotton Research Conference in Armidale in November 2019 to report the work of a CRDC and DPI project, DAN 1505, benchmarking water productivity in Australian cotton. As you can see, there's a few of us working on this project, this aspect of the project, and what we're trying to do is use a new technique, data envelopment analysis, to examine how productivity can change in Australian cotton. So the talk will examine briefly data envelopment analysis, or DEA, how we can use DEA to assess water efficiency using cotton gin data, and have a quick look at the conclusions that we draw from this work and future directions we may take. So DEA is a mathematical method which finds the production frontier and the relative efficiency of firms or entities within the area that we're working in. So let's have a look at a quick example. If we consider 6 firms using inputs to produce outputs, A, B, C, D, E, and F, we can draw a frontier, and their inputs are irrigation, megalitres per hectare, and yield, bales per hectare. We can draw a frontier around those who are using the most water most efficiently to produce that cotton. And we can see that in this picture with the black line. The efficiency with which field F produces cotton is shown by the difference between this distance F to F0 and A to F0. So if F was actually on the frontier at A, F0 to F equals the efficiency of field F is measured by dividing this distance here, A to F0, by the distance F to F0. So if F was on the frontier, that would be 1, they would be 100% efficient. In this case, they're probably about 40% efficient because they're not on the frontier. So we can see here that farm F is 40% efficient because it is a distance 8.5 from the y-axis, and the frontier is a distance 3.5. Divide 3.5 by 8.5, you get 0.4, 40% efficient. If you do that calculation for all the fields, you can see their efficiency ranges from 1 on the frontier down to 0.4 F, the least efficient field. That gives us an average efficiency of 0.77 for that group of fields. They might be in a region or fields owned by a particular farm or business. So it gives a way of comparing how efficiently water is used between farms, fields, or entities. When we do the calculation for irrigation water use efficiency, you can see that varies between about 1.2 bales per megalitre down to 0.7 bales per megalitre. That value is 0.97 as an average, regardless of where we are. Okay, how can we become more efficient? We can do that by moving towards the frontier. You can move in a number of different directions to get there. So field B can move from here to here, field F can move from there to there, field D can move from there to there, generally moving towards the frontier. What impact does that have on their efficiency? As you can see there, they've all improved, gone up to 0.9 in the case of field B, 0.66 in D, and F has gone up from 0.4 as it was in the previous example to 0.75. The overall efficiency of that group of fields has gone up to 0.85. Irrigation water use efficiency has gone up to 0.104. On average, it was 0.97. So you can see both measures improve by shifting towards the frontier. So let's have a look at some real data now rather than a hypothetical example. This is 2017-18 data from the Rivcot Gin at Colliamberley. We've divided it into 5 regions. We've got 410 fields. There was a lot of ancillary data collected with the water and yield data, so we've got 63 variables that we can actually try to explain changes in differences in efficiency. Of those 410 fields, we had 234 with useful data. You can see here the regions that we've got divided. So we've got Carrathool, Griffith, Whitton, Colliamberley, and the south, which is essentially the Murray Valley. When we plot these out as you would in a DEA analysis, you can see we've got a fair bit of scatter. We've got all the data here together. We've got 3 fields which define the frontier. You can see there's a large spread. The mean efficiency of this group of fields is 0.76, but some fields are a long way from the frontier. These guys out here only have an efficiency of 0.55. So the first thing we did was to look for regional patterns in these. And you can see there are, and generally the south tend to be close to the frontier, more water efficient. And as these guys here, Whitton, Murray, are a wee bit further away. Have a look what that looked like in general on a table. So you can see here, again, we had a decent spread of farms within the different regions. The water efficiency measured by DEA varied from 0.83 in the south, the highest, down to 0.72 at Colliamberley. And interestingly, that's fairly well paralleled by bales per megalitre irrigation used. So the average overall was 0.88 and 0.18 here. So let's focus on Colliamberley as an example, because Colliamberley here had the lowest efficiency when compared to its the rest of the regions, the rest of the data that we collected in this particular year. So if we just look at the Colliamberley data, the black dots on this diagram, we can draw a frontier around the Colliamberley data, and you can see that as the dotted line there, and we can analyze them on their own. As you can see, because we're just using the data to define the productivity frontier, most of the Colliamberley fields are much closer to their own frontier. So when we do that for all the regions, we find that compared to the fields within that particular group, the average efficiency of all the fields in Colliamberley went up to 0.86, and within each region, the fields are pretty well using water as efficiently as they can. Water use will not change because that's defined by how much water you put on. The water efficiency is defined by how you compare to the rest of the group in your region. So the findings that we've pulled from this, the advantage of using DEA, it's an economical way to do things. We got a lot of data quite easily without having to do a lot of survey work and put an impost on growers or consultants. It's pretty effective and simple. And it will, when we get further down into the data, identify if human or other drivers are barriers to high water use efficiency. The disadvantage of this technique is it measures inputs which are rounded, and you can see from the diagrams that things tend to be in straight lines. That's because things get rounded to the nearest megaliter when they are recorded. It measures also only irrigation water use efficiency, but we could have a guess at the GPWUI by adding rainfall to irrigation water. And in the future, we like to use this technique to identify drivers. We're repeating it for the 18-19 season, and we've got the data for that, and it could be applied to other regions and gins, and also other inputs such as nitrogen. Thank you.